Hey, good afternoon, Chem 1110 students. Today, we're going to be going over some topics that I had a review video over, and I also have a preview video. And these are also some topics that are covered really extensively in your textbook. And we're going to begin with section E4 today. Section E4 involves significant figures, and I like to call them sig figs, and how we use significant figures in calculations. The first stop in our little discussion is going to be on how we use significant figures when we're conducting addition and subtraction, because there are different rules between addition, subtraction, and between multiplication and division. So for addition and subtraction, we're limited by the number with least number of decimal places. In other words, we're limited by decimal position when we're carrying out any type of calculation involving addition or subtraction. I have an example for today. These are very similar to a few textbook problems that you can easily find. And there is one in your textbooks, example E4, good example to go through. So let's go through this example here. We're just going to add some numbers, and we're going to report the number of significant figures associated with our answer. So the question is, let's find out what our product is when we add 1.028. And I like to add these together in a column, sort of like we did in grade school, plus 2.69. Now, when we're adding these two numbers up, most people are just going to put them in their calculator. But I like to write them out and understand a little bit about what we mean by we're limited by decimal position. Our answer that we get for this addition step is simply limited by the number that has the least decimal positions. And in this case, 2.69 only has decimal up to the 100th position. So what I like to do is draw a line. I like to put a line, sometimes a dotted line. Let's just use a solid line so everyone can see that. We're going to put a solid line there so we know where we're limited at when we do our addition step. So if we add these up, again, you can do it in a calculator, or you can do these by hand like you did maybe in grade school. You're going to get an answer of 3.718. Okay, we're limited to the hundredths position because 2.69 is the number with the least number of decimal places. It's limited to the hundredths position also. So when we report our answer, the answer that we get would be limited to the second decimal place. But also we need to remember rounding rules that we may have learned maybe in a math class earlier in our life. When we're dropping this 8, what that tells us, any number greater than a number 5 or greater. 5 or greater, we round up. If it's less than 5, we would retain that. Since this is 8, we're going to round this up, and we're going to get an answer for this step, 3.72. We're limited to the hundredths position, and since we're dropping the 8 off, we round that number up and we get 3.72. Any questions? Let's move to multiplication and division. A different set of rules. When we conduct any type of exercise involving multiplication or division, we have a different rule. In these steps, we're limited by the number with the least number of significant figures. And I'm just going to write least sig figs. How's that? Let's do another example. Example where we're probably just going to use our calculator. And let's read this example. The example says, let's report the following and use scientific notation. So this is a good practice example. 479.1. And we're going to divide that by a number 0.082. And I have it in parentheses just so it's easier to read. Sometimes I'll do that. Put them in parentheses. It's easy to read. We would plug these into our calculator. That's probably the easiest way to do it. That's how I would do it. If we plug these into our calculator, and remember, the question is place your answer in scientific notation. Plug these numbers into your calculator. You're going to get a string of numbers. 584, 5842.682,927. Okay, we're working in the lab. What if we were reporting this and there were units with it and we were using this in our lab notebook? Okay, we can't report all these. That's just giving us too much precision. We don't know this last decimal place. Our calculator will give that to us, but we don't know using the measuring device that far out in terms of where we're going to be reporting our data. In this case, when we do multiplication or division, such as in this example, we're limited with our answer by the number that has the least number of significant figures. The number that has the least number of significant figures is the number in the denominator. 0.082 has only 2 significant figures. The 8 and the 2 are the only 2 significant figures in this example. Therefore, our answer has to have 2 significant figures also. So our question asked us to report it using scientific notation. So let's go ahead and report this with scientific notation. So if we move our decimal 1, 2, 3 positions to the left, 5.842682927. And since we're moving it 3 positions to the left, that would be times 10 to the third. But remember, we're limited to 2 significant figures. These numbers we're not going to use. And since this number, the last number that we're dropping, is less than 5, we're not going to round up. Our answer would be 5.8 times 10 to the third. Good so far? Doing good? Exponents. We use exponents a lot in science. When we use exponents, we use the same rules we do for multiplication and division. If we think about squaring a number, it's basically multiplying that number by itself 2 times. So we use the same rules we would use for multiplication and division. Let's look at another example I have. And again, the question asks us to report our answer using scientific notation. 0.0681. And we're going to square it. So again, probably easy enough just to throw this in your calculator. And if we put this in our calculator and we hit the equal button, we're going to get a number, a small number, very small number. 0.00463,761. Okay. Now, this tells us that we're limited to 3 significant figures because this number only has 3 significant figures. The 6, the 8, and the 1 are significant. Our answer is only going to have 3 significant figures. And once again, this problem asks us specifically, you don't have to do it unless the answer says specifically, put the answer into scientific notation. So in this case, 1, 2, 3. We move our decimal 3 positions to the right. So that would be 10 to the negative third. And then we're limited to 3 significant figures where we're gonna drop that data off. And since this number, the last number that we're dropping off is 5 or greater, we're gonna round up. And this would be the correct answer when we're squaring a number. We're using exponents. We use the same rules as we did for multiplication and division. We're going to try one more problem. Multi-step operations. These are operations in which we do 2 or more steps. And the idea here that's important is we do not round between steps. We lose information. So when we conduct 2 or more steps, we retain all of our data and round at the end of the problem. Problem is involving more than 1 step. These are 2 or more steps. 6.781 times, I'm sorry, 6.78, my bad, 6.78 times 5.903 multiplied, I'm going to move it over a little bit. This is getting messy, sorry. 6.78 times 5.903 multiplied by, within parentheses, 5.489 minus 5.01. So we have multiple steps in this operation. And what's also important is we have both multiplication and addition and subtraction. So this gets a little bit confusing. But if we remember what we learned probably a while ago, maybe in a math class in high school, or maybe even earlier for some people, are rules for operations. When we're given an operation like this, the first thing we do is work within our parentheses. And within our parentheses, in this case, we need to use our rules for addition and subtraction. So let's work within the parentheses. And we would recognize in this step, we would draw our line. We would subtract 5.01 from 5.489, and we're going to get an answer 0.479. Okay, let's think about what we're going to do in our next step. Remember, we said it's important not to lose data. Don't round off between steps because we still have some more steps to conduct. We have to multiply these other numbers by this difference between those two numbers. So what we're going to do is we're going to retain all of our data from this step, but we're going to remember from this step, if we were done, we would be limited to the hundredths position. So we need to remember that when we do our next step. We need to remember that. So let's put this number in parentheses, the answer for that step right there. We're going to put that into our parentheses, 0.479. And now we want to remember that if in this answer, we're really only limited to the hundreds, but we're going to keep all of our data because it's important not to round. I like to put some kind of indicator in that data that if we were done at that step, we would be limited to the hundredths position. So I normally just put a little line over the spot where I'm limited at in that step if I was finished with my problem. Let's just multiply these numbers out. Let's multiply. Put this into our calculator, multiply by that, multiplied by our answer, and we're going to get a number 19.1707086. And now we got to ask ourselves, how many significant figures are we limited to in our answer? Remember the rules for multiplication and division. We're limited by the number with the least number of significant figures. 6.78 has 3 significant figures. 5.903 has 4 significant figures. How many significant figures are there in that answer? Remember, we put a little cap over top of where we would end at in terms of the number of significant figures that piece of data truly has. This piece of data really only has 2 significant figures. Do we see that cap? That cap is telling us that the 4 and the 7 are our 2 significant figures in that number. Therefore, this number limits our answer when we report our data. We only have 2 significant figures. I would report it as 19. But once again, this problem, just because it asks us to place the number in scientific notation. We would imagine a decimal. We would move it 1 position, 1.9 times 10. You can write a 1, but you don't have to. If there's a 1 there, we don't really write the 1, but if you want to, I'm not going to have a fit or heart attack. That would be the correct answer for that exercise. That's the mathematics for significant figures. And if you have any questions, send me an email, come to my office hours through Zoom. We're going to do a second part dealing with density and then go into problems, how to solve problems. Hey, thanks a lot. Have a good afternoon. I'll see you in part 2.